Let's see another common problem that is asked in Facebook interviews, and it's from LeetCode, problem number 122, and it's called best time to buy and sell stock, and its version is 2 because there is one simpler version also, version 1. This is version 2. So let's see the problem. So you are given the stock prices on different dates. So this one cell denotes one date. On a particular date, what was the mean price of the stock? And obviously stock prices cannot be negative, so these are positive numbers. And you have to calculate what is the maximum profit that you could have made. This is not a trading strategy. You cannot follow in real trade. It's just that one day back, you could have made this much profit, but you did not. So the idea here is that whenever a stock price dips, you mark this into a variable called buy. So you buy at this price. Let's say it dips further. So you update your buy to hold this value. And when it's moving up, you don't do anything. Your buy is still here. Till the moment it keeps decreasing, you have keep updating the buy. And till the time it's increasing, you don't do anything. You sit idle. You could have also sold here, then bought again, sold again, but there is no point in that. You wait till it keeps going up. And let's say here it dips. So what you will do, when you reach here, you see that today's price is lower than yesterday's. So you sell it at this price. So, and you keep accumulating profit. So whatever was the profit till now you had made, you add this much to your profit. So this denotes one transaction. And now your new buy is this one. And if it decreases further, you will update your buy. And when it increases, you sit idle. And now again, so let's call it B1, S1, B2 is this. And the moment it dips, you sell. So you again add S2 minus B2. So this is the strategy and it will work. You are allowed to make as many transactions as you want. But there is a scenario which I have not considered here. Let's say here this was the end of the array, or maybe this. So you got a chance to sell, but there may be a situation that this was the end of array. That is, you bought here, but you did not encounter a dip in price. So you never got a chance to sell. So you are not adding this part to your total profit. So we will handle that case separately. That if we bought and we have completed the entire loop, the complete iteration of this array, then we will add the last price. If it's in array A, then we will add n-1 minus whatever was the latest buy. So let's write code for this. And again, I'm warning you, this is not like it works in stock market, because you never get to sell, go back in time and sell. It's just to aggravate your grief that I lost. I could have made this much profit theoretically, but I did not. So this is just as a retrospective method. Although people follow something very close to this, they don't sell till the moment it's increasing. And they also keep a stop loss, which is some small threshold. Let's say this. So if the price is here, they will always keep a stop loss of T below the current price. So if it dips by more than this T amount, it will automatically get sold. And when it price increases, they increase the stop loss also. So it's always lagging by T amount. So if it reaches peak, then stop loss was here. And when it falls, then it will be sold at this price. So the idea is not to sell at the peak, but close to peak. So this was just some extra info. There are, of course, many more complex tricks that traders apply for their trading. Let's quickly write the code for this without going too much deep into day trading or long-term trading. So if first thing is that if there is just one price, then you cannot make a transaction. You need to buy at some price, sell at some price. With one, you can make a transaction that you buy at that price and sell at that price. But profit will be again 0. And why would you do that? So you can return safely 0 in this case if it's 1 or less. Then this is the buy I was telling about here, that we initialize this buy whenever there is a dip, and we keep updating till there is a dip. So initially it will be prices 0 and profit of course is 0 in the beginning. So now we will start iterating from 1 because we will compare if 1 is less than 0 or not. So our loop should start from 1. I less than prices dot size and plus plus I. Then if current price is I is less than prices I minus 1. This denotes price drop. So whenever price drops, do we need to update profit here? I think we can just update. Okay, so we need to add to the. So whenever there is a dip, we sell. So we make a transaction. So what we will do, we will subtract previous price, not the current price, minus buy. So that we need to write here profit plus equal to prices I minus 1 minus whatever was the buy price. And we do additional step, that is we update the buy to the current price. And I think we are done. This should work for all the cases, but as seen here, the last case, if we bought but we did not encounter a dip in the end, then we need to add additional case for this one. So we will write profit plus equal to prices dot size minus 1. This is the last index minus buy. And we don't need to keep any check here. We can always put it here because let's say if it was the peak in the end, then it will automatically add this profit which was not added. But let's say if it was this one and the buy was this, here again we encountered a dip, so we would have again updated buy. So buy was pointing to the last price, that is A of n minus 1, and we are doing profit plus equal to price of A n minus 1 minus buy. But this buy is nothing but A n minus 1, so it will be 0. So adding 0 will not change anything in the profit, so we don't need any condition here. And then we need to return the profit. And let's try to run our code. It passes for our base case. Let's submit if we are confident. I think this is a simple problem. We can be confident, and it's quite good, close to 100%, and in space also it's close to 100%. So that's it.